Suppose we have a positive charge q1. Now, I bring another positive charge, q2 near to it.
Now from Coulomb's law we know they exert equal and opposite force on each other. Let F12 be the force acting on charge q1 due to q2. At the same time charge q1 also exerts force on q2, that is F21. But now we don't consider force F21, we just consider the force upon charge q1 only. Similarly, if I bring another positive charge q3, then it exerts a force F13 on charge q1. So here superposition principle of electrostatics says that the force F12 will never going to affect the force F13. These forces have independent effect on charge q1. So we can say the charges behave independent of each other. Mrs. Ipsita had a son. His name was Ram, and she loved him so much. After some years, she was blessed with another son and she named her Shyam. Now, tell me, will mother's love decrease for Ram? Will mother's love for Ram affected due to Shyam? No. Mrs. Ipsita loved them equally. So both brothers were independently getting the same love from mother. Similarly, appearance of one force does not affect the another force. All the forces are independent of each other. That means charges behave independent of each other. Suppose now we have another charge q4. It produces some force, that is F14 on charge q1. Now we have three forces acting on charge q1. And as I said, these forces behave independent of each other. So, here, what will be the total force or net force acting on charge q1? For net force we have to add all the forces. So we just do vector sum of all the forces.
Let's go to the statement of this principle.
It states that all the charges when placed near each other behave independent of each other, and the net force on one charge due to all other charges is equal to the vector sum of all forces produced by them on that one charge, in accordance with Coulomb's law. So, we have considered a charge system having similar charges q1, q2, q3, and q4, which are represented by the position vectors r1, r2, r3 and r4. Here we have taken the origin as our observation point. Since these charges are of similar nature, so obviously they exert force of repulsion between them. Now, our aim is to find the net force or total force of the system. So first of all, we have to find the net force on each charge, then only we can find the net force of the system. First, I have considered q1 charge and the force of repulsion on it due to other charges, are shown on the figure. Force acting on charge q1 due to charge q2 is given F12 vector. Force acting on charge q1 due to charge q3 is given F13 vector. Force acting on charge q1 due to charge q4 is given F14 vector. Let's draw the displacement vectors. Let r21 vector be the displacement vector from charge q2 to q1, and r12 vector be the displacement vector from q1 to q2. According to Coulomb's law, force acting on charge q1 due to charge q2 is given as equals to k into q1 into q2 divided by the square of distance between them. For distance you can take mod of either r12 vector or r21 vector. Though, see in the diagram, they are opposite in direction but equal in magnitude. Now let's assign the vector sign over the force. Let me remind you here, a vector quantity has both magnitude and direction. For example, here a vector is equal to product of a vector mod, that's its magnitude, and a cap, that is its direction. So just inserting an arrow will not create a vector. We have to see if there is any direction with magnitude. But we don't see any directional term on right hand side. We have to multiply a direction on right hand side. Obviously, to become equal, both left hand side and right hand side should have same direction. So, we multiply the direction of same F12 vector on right hand side. Now observe, The direction of displacement vector r21 and f12 are same. So we can replace the direction of f12 vector with direction of r21 vector. So writing it as r21 cap. Since we know r vector is equal to the product of magnitude of r vector and its direction r cap. From this just put the value of r cap in the equation. Combine the denominator. It becomes r21 vector mod cube. Now we can write the displacement vector r21 in terms of position vectors, that is, r1 vector minus r2 vector. Similarly, we can find f13 vector and f14 vector. Here the value of k, that is constant of proportionality, for air medium, in SI unit, it is 1 by 4 pi epsilon naught, and in CGS unit, it is 1. For medium other than vacuum, it is 1 by 4 pi epsilon. Now let's add all these forces to find the net force on charge Q1. Net force acting on charge Q1 is given by F1 vector, which equals to F12 vector plus F13 vector plus F14 vector. Now put the values that we have got from above. In this way, we can find the net force, or total force on charge Q2, Q3, and Q4. So in general we can write it in terms of summation, where the value of I and j goes from 1 to any larger number. But you should be careful that the value of I and j should not be equal. Suppose if we take same value for both I and j, that is, I equals to 1 and j equals to 1, then we get a force, which means we are calculating force of a charge on itself, which sounds meaningless. So, I and j should not be equal. Now, by putting different values of I, we can get F1, F2, F3 and so on. That are the net forces on charges Q1, Q2, Q3 and so on. So just write down, net force of the system is F vector equals to F1 vector plus F2 vector plus F3 vector and so on. We can write the same by using summation. Now put the value of Fi vector here. K is just a constant, so take it outside. So finally this is the required expression for net force of the system of charges. This is all about the superposition principle and derivation of net force for a system of charges. I hope you liked the content. Subscribe to the channel and press the bell icon for more updates.